In this video, we're looking at tangents from an external point. So in this theorem, the external point here is P, and we're going to draw a couple of tangents. So this one here going through A, and this one here going through B. Just a reminder about what a tangent is. So if I have a tangent, and it just touches the circle of point, that's a tangent. If instead my line goes off like that, it is not. Or if it cuts through the circle, it is not. All right, so what we know about it when we have a situation like this is that these two angles end up being the same angle, and also these two side lengths end up being the same. So the length of AP is the same as the length of BP, and that's what our theorem says. So let's do a couple of examples. So PA and PB are both tangents with center O. Find angle OPA. Now this is a direct application of our theorem. Angle OPA equals angle OPB. And this is by our theorem, which is called tangents from external point. Great. Therefore, angle OPA has to be, well, the same, 31 degrees. Cool. Next question we have kind of goes on from this, so I'm going to start by filling out that as 31 degrees. PA and PB are both tangents to the circle. Find angle ABP. So the angle we're actually looking for isn't on the diagram yet, but it will be. Angle ABP is that angle in there. That's what we're looking for. Okay, cool. So a couple things we could do. You can potentially assume that's a right angle, but that's a bit dangerous. We can do it without assuming it's a right angle. So let's look at this triangle. We can use our theorem to say that length and that length are the same. So AP equals BP by tangent from external point theorem. Then what does that tell us? Well, it tells us, therefore, triangle APB is isosceles. Now, it's really important because what do we know about isosceles triangles? Well, they're defined by having two sides that are the same length, and that tells you both these angles in here are the same. So really importantly, this angle in here and that angle that we're looking for is the same. Therefore, angle PAB equals angle ABP. Now, that's great because we have the other angles in this triangle. So 62 plus angle PAB plus angle ABP should all add up to 180 because of the sum of angles in our triangle, which is triangle ABP. Great, so when I'm looking at this triangle here, all those angles should add up to 180. Let's check that. So 62 plus, now I'm going to call both of these angles ABP. $180. And sometimes I like to do this. I like to label it as like star, and then I say from star, something like that. Therefore, angle, well, two lots of angle ABP equals 180 take 62, which is going to be 118. Therefore, angle ABP is going to be half of 118, or in other words, 59 degrees, which is great. So if I look at all the angles in this triangle, let's check they do add up to 180. So I have 59 two times, and then I also have, well, these two lots of 31, which give me that angle being 62, but it should all add up to 180. So that's great. Last one we have, the quadrilateral has a perimeter of 20 centimeters and the circle has a radius of 4. Now, you might be wondering what a quadrilateral is, and the answer is it's a four-sided shape. So for example, squares and rectangles and parallelograms are all quadrilaterals. So got that line there, A, O, O to B, B to P. So that's how we read it off, A, O, B, P. And then you got to have that last edge in there. That's the quadrilateral we're looking at. And the perimeter equals 20. Cool. So we know a few of these sides already. So the circle has a radius of 4. And also from the radius tangent theorem, not the radius tangent, the tangents from a point theorem, we get that these two are the same. Let's call that x. So let AP equal x, then BP equals AP, which equals x, by tangent from external point theorem. Cool. So then we have x plus 4 plus 4 should equal that perimeter being 20. So 2x plus 8 equals 20. So 2x equals 12, which means x has to be 6 centimeters. Cool. And that's our length we're looking for.